Okay, today we are going to be talking about radicals again. Just so you guys remember, radicals are just going to be our square roots, could be our cubed roots, could even be a fifth root. So we do 32 in there. Okay, radicals are just roots. Now, we've found that when we are trying to add roots together, like if I have a square root of 2 plus a square root of 5, we're not capable of doing that. And so basically, what we're going to make the point of today is that we've got all of these rules for exponents, our laws of exponents. And this is all stuff that we've gone over before. Anything to the 0 power gives me 1. Negatives, they flip what side of the fraction they're on. If you multiply into the same base together, you can add them together. And essentially what we're going to find out today is basically that it would be very handy if we could write radicals as exponents. Because then if we could write radicals as exponents, all of these rules would also apply to our radical signs. And the good news is that we can write radicals as exponents. So we can write square roots as exponents. And in order to do that, we're going to be talking about fractional exponents. Okay, you may also hear them called rational exponents. And remember, rational numbers, okay, your rational numbers just means that they are fractions. Anything that's rational can be written as a fraction. So, starting out then. First off, what is the form of a rational exponent? Well, if I have the jth root of a to the m power. So again, the jth root of a to the m power. We can rewrite that as a to the m over j power. Okay, so whatever the exponent was goes to the top. Whatever the root part was goes to the bottom of the fraction. So, how can we remember that? Well, the way that I tell kids to remember this is just to remember jam, as in someone dunking a basketball. So if you remember jam, and then you remember this picture right here, you can clearly see Mr. Schieber dunking over Penny High's own Jaron Richmond. Okay, so remember jam, and then that Mr. Schieber dunked on Jaron Richmond. Okay, so if I have the jth root of a to the m power, that's going to equal a to the Mr. Schieber dunked over Jaron. Okay, so I always tell them to remember jam. So let's practice with our jam real quick. Okay, starting out, I've got 10 to the 1/4 power. So again, remember jam. Okay, we're remembering jam. Remember that Mr. Schieber dunked over Jaron. So that 4 is in the same spot as my j up here. Okay, so this is going to equal a 4th root of 10 to the 1st power, which is really just the 4th root of 10. 10 to the 1st power would just be 10. Okay, now we're not going to be able to simplify that any further than that. Okay, next, I've got p to the 5/2 power. Okay, so again, 2 is on the bottom, 2 is in the j spot. Okay, so that's going to be the 2nd root of p to the 5th power. Now, I do have one question. Have you guys ever seen a 2nd root out there? Probably not. You shouldn't have. Okay, and that's because that is a square root. That's a square root. So typically, when I see a square root, I'm going to write it just like this. Okay, we do not need to write the 2 because the 2 is implied that it's going to be there. So if you ever have a 2 on the bottom here, that's fine to write it like that, but your final answer should not have the 2. Okay? Let's do a couple more. Now we're going to work the other way. Okay, I've got, wow, the square root of x. Okay, now I'm looking up here at this one. I've got jam, okay, but there's no numbers at all. Well, remember, if there's no number here, that's actually a 2, because that's a square root. And if I don't have an exponent, x to what power? What power is that? Well, if there's no exponent there, that's just an x to the first power. Okay, so this here is going to equal an x to the, okay, my j is a 2, so that's going to go on the bottom of the fraction. And my m is a 1, so that's going to go on top. That's x to the 1/2 power. Okay, that's going to be an x to the 1/2 power. All right, then our last one, I've got an L, the 7th root of L cubed. Okay, well, this is my J, so that's going to go on the bottom of the fraction. That's my M, so that's going to go on top. So that's L to the 3/7 power. Okay, and that's essentially the main part of what today's lesson is. You need to be able to jump back and forth between these two. And then what are the benefits of jumping back and forth between these two? Well, one of the benefits are that you're going to be able to simplify some of these without using a calculator. Okay, so if we remember, we've got jam. There's my jam. Okay, and that equals A to the Mr. Schieber dunked over Jaron. Okay, so when I have 8 to the 2/3 power, that's going to be the cubed root of 8 squared. Okay, now one of the interesting tricks that you guys can do with these, because if I'm doing order of operations on this case here, I'm going to do 8 squared and then I'm going to take the cubed root. But these are actually interchangeable. So I could also write this as the cubed root of 8 and then square it. Okay, these two things here equal the same thing. And what you're going to find is when you are simplifying numbers like we have here, this is the one that you're going to want to use. Typically, we're going to use this one. Okay, but when we are simplifying with numbers, this is the type that we want to use. But they're both interchangeable with each other. Okay, and the reason that this one's more helpful is most of us should know what the cubed root of 8 is. That's going to give us 2. So I end up with 2 squared, and that is 4. Okay, if I tried to do it this way, I'd get the cubed root of 64. And not as many of us know what the cubed root of 64 is. We haven't talked about that as much. So that's typically why we want to write it like this one here. Okay, so let's try another one. I've got 16 to the 3/4 power. Well, by my jam rules, that's a 4th root of 16 cubed. Okay, well, I probably want to write this the other way, 4th root of 16 cubed. Okay, now we may not know the 4th root of 16 off the top of our head, but it's going to be easier to figure out than the other way. Okay, well, 2 times 2 times 2, that gives me 8. Times another 2, that gives me 16. So the 4th root of 16 is 2 again. And 2 cubed gives me 8. So 16 to the 3/4 power equals 8. Okay. And then last, I've got 37 to the 4/3 power. That's definitely wrong. That is definitely supposed to be 27. Sorry about that. 27 to the 4/3 power. Okay, if I write this out, that gives me the cubed root of 27 to the 4th power. So cubed root of 27 to the 4th power. Well, that's not going to help us too much, but we could do the cubed root of 27 to the 4th power. 3 times 3 is 9. Times another 3 would be 27, which means that the cubed root of 27 is 3. And then I've got to take 3 to the 4th power. That's just a 3 squared times a 3 squared, so 9 and 9. 9 times 9 is 81. Okay, now, this is helpful to teach you guys to simplify. I want you guys to show your work like this when you're working on problems on your notes, because it's going to help you remember your jam rule, and that jam rule is going to be important. However, you can also plug these in your calculators. Okay, I can plug 8 to the 2/3 power in my calculator. Be 8 caret, whoops, That's the wrong way to draw a caret, my bad. 8 caret. You're going to want to use parentheses. 2 divided by 3. Okay. You can plug that in your calculator. That will give you your answer. So that's a good way to check yourself, but you still need to show your work. Okay. I still want to see your guys' work. All right. Next problem. Okay. Like I said, it'd be handy if we could do some of these problems, okay, using our rules of exponents. So our rules of exponents still apply, okay, to these radicals. And what I have up here is I have a bunch of these that are radicals. Okay, that would be the 12th root of 125 cubed. This one here would be the 12th root of 125. I've got the square root of 9 to the 7th power, the square root of 9 cubed. Okay, so I have a bunch of radicals up here. I've just written them with fractional exponents instead of radicals. And that allows me to apply my rules of exponents. So if I have the same base here and they're being multiplied, I can just add their exponents together. Okay? So that's going to give me a 125 to the 4/12 power. I add 3/12 and 1/12 together to give me 4/12. Now, 4 over 12, I can reduce that, and that reduces to 1/3. And now I can use my jam rule, jam, okay, which remember Mr. Sieber dunked over Jaron. Okay, I can use my jam rule and rewrite this. If I have something to the 1/3 power, that's a cubed root of 125 to the first power, which is just a cubed root of 125. And that tells me that my answer to this question is 5, because the cubed root of 125 is 5. So this complex thing that we started with up here is actually just the number 5. Okay, next, if I have them in fractions, again, I have the same base. We can cancel. I've got 3 halves on the bottom. I could cancel those 3 halves. I just have to take away 3 halves from up top here. So if I take away 3 halves from that, I'm going to be left with 4 halves. So I'm left with 9 4 halves. Well, what is 4 halves? That's just going to give me 2. 4 divided by 2 is 2. And 9 squared is 81. Okay, if I have a power to a power like I have here, power to a power, we would multiply these together. Okay, so that gives me 3 to the 6th power times 1/2. That's going to give me 3 cubed. And 3 cubed, we already talked about, gives me 27. Okay, now if I think about this one here, okay, something to the 1/2 power. If I'm looking at jam, the 2 goes out here, the 1 goes in here. Okay, so this is really a square root of 3 to the 6th power. Well, we don't need to write the 2 there, so square root of 3 to the 6th power. Okay, we've done this before. That's 6 3s up there, right? Okay, and since it's a square root, we're looking for pairs. How many pairs can I pull out? Well, I can pull out 3. So another way to think of this is really a 3 to the 6 over 2 power. Okay, 6 3s divided into groups of 2. 6 divided by 2 gave me my 3. Okay, that's why this radical troll thing that we talked about before, that's why that works. Okay, all right. Then my last one, I've got a 1/4 over here. Well, this 1/4 goes to both. So that's 16 to the 1/4 power, and that's 625 to the 1/4 power. Okay, 1/4 power means I'm looking for the 4th root. So this is the 4th root of 16 times the 4th root of 625. Okay, if you don't know those, you can always plug them in your calculator. 4th root of 16 is 2. 4th root of 625 is 5. And 2 times 5 gives me 10. Okay, but the point of this slide here is just showing you guys all those rules of exponents that we have now apply also to our radicals if we can remember how to write them in their standard form.